All right, so before we continue, please make sure that you have this note sheet pasted in your notebooks. And also, if there are any notes from yesterday or 2 days ago that you have not yet pasted in your notebook, make sure that you put them in there as well, just so at the end of the year you can have everything all together when it comes to study for the OAAs. All right, so our learning target, like I said before, I can model descriptive data by constructing a linear equation. We're going to break this down into two smaller goals. The first goal, I can identify the initial condition. And remember, I am going to be checking these and you'll be graded on completeness of your notes and your notebook. Our second goal is I can calculate the rate of change. So as we're working through these examples, just keep both of those goals in mind. Okay, we're trying to find the initial condition and we're trying to find the rate of change. I'm going to stay on these two words just for a minute because our rate of change, we've been calling this by a different name, but we've actually been finding the rate of change for quite some time. Look back in your notes and see if you can find another word for rate of change, or just think about it for a minute. All right, hopefully some people said that this is the slope. So when we talk about in these problems finding the rate of change, really I'm talking about finding the slope of whatever data we're given. The second thing, the initial condition, hopefully by now we know that there are two things required to write the equation of any line, the slope and the y-intercept. So if the rate of change is represented by the slope, or I should say the slope is represented by the rate of change, our initial condition we can call B, or the y-intercept. Please make sure that you have all of these vocabulary words and variables written down, okay, because it's going to be important. You'll see the y-intercept sometimes referred to as the initial condition or the initial value. Sometimes you'll see it referred to as B, and the same thing for the rate of change. So make sure you've got that in your notes. All right, so if you notice, we've really got two problems on here. One is this paragraph problem, and the second is this chart. Okay, and these are actually the same charts, just we're breaking it down into our first goal and our second goal. We're going to start with the paragraph problems. By the end of today, you should be able to do both, but for now, let's just start with this. So it says, Avian is a car salesperson. She earns $30,000 per year, plus $250 for each car sold. So if I want to make a graph that shows Avian's salary based on the number of cars she's sold. So for instance, if I had a graph where, I'm just going to come down here for a minute and write it, I guess I'll put it here, like this, and this is the money, her salary, and on my x-axis I have number of cars sold. If I want to graph this, okay, I need to identify two things. Just like everything else, I need to identify my y-intercept, or my initial condition, which in this case, think about what that means. Okay, the point on this line, this is going to be the amount of money that Avian earns if she sells how many cars? Okay, the answer is 0. If Avian sells no cars at all, her salary will be this number. If she sells 1 car, it will go up by a certain amount. If she sells 2 cars, it will go up by that same amount, and so forth. This is kind of, if you can picture what the graph would look like, this is it. So our first goal, I can identify the initial condition. In this case, it says what does the initial condition represent? In this case, it represents Avian's salary if she doesn't sell any cars. So Avian's salary if she sells 0 cars. So that answers the first part of our question, what does it represent? Or the second part, I should say. So now, what is the initial condition? What is it? We've really only got 2 numbers to work with here. We've got 30,000 and we've got 250. So if our initial condition represents Avian's salary if she sells 0 cars, which one is it? Does she earn $30,000 or $250? Okay, the answer is 30,000 because she earns $30,000 per year. And if she sells no cars, that's it. It's cut off there. Once she sells one car, then we add 250. So now it's 30,250. If she sells two cars, we add another 250 and it goes up from there. But our initial condition is just how many cars she sells, or I'm sorry, her salary if she sells 0 cars. Our initial condition is her salary if she sells no cars whatsoever, her base salary. And in this case, it is 30,000. So now, take a minute, make sure you've got all that copied. Then we'll talk about our rate of change, or our slope. So what does the rate of change represent? Well, think about it for a minute and write it down, and then I'll come back and we'll talk about it. But really write down what you think the rate of change for this problem represents in words. How would you describe it? Use your vocabulary, some vocabulary words from the problem itself. All right, so our rate of change or slope, I'm going to say the rate of change represents the amount of money that Avian's salary increases per car. So I'm going to say the amount her salary goes up for each car she sells. So now that we've answered that question, her rate of change represents the amount her salary will increase for each car that she sells. Let's figure out what is the rate of change. Well, since this is a paragraph problem and it's pretty easy, there's only 2 numbers to work with. We know it's not 30,000 because that was our initial condition. How about 250? Okay, so the rate of change is $250. So that means if I found the slope, if I plotted all of these things, going back to the graph and the way the graph looks, 0 cars, she's at 30,000. At 1 car, it goes up $250. And then it's going to keep going up by $250. Really, there should be a 3rd column because remember our goal was to ultimately construct a linear equation. We don't have an equation yet. We've accomplished finding the initial condition. We found the rate of change, but we haven't put it all together to find an equation, to write an equation. So I'm just going to come down here because that's where I have room. And I'm just going to say goal number 3 is to write the actual equation. Write the equation. And if you want to, pause this right now and go back, look in your notes. What is the general form of a linear equation? And then remember from a few days ago, we have to make a correct substitution, substituting the slope and the y-intercept, or the rate of change and the initial condition. So if you want to pause it right now, go ahead and do that and try it on your own. If not, we'll just say that our line, or the amount, Avian's salary, is represented by y equals mx, so our slope, 250x, plus b, or our initial condition, which in this case is 30,000. Okay, so there's our equation. We have accomplished it. We have read a paragraph describing a situation. We found the initial condition. Check that off. We found the rate of change. Check that off. And then finally, we put it all together to make an equation. Okay. So now let's go up to the chart. The chart is a little bit more work, but it's the same idea. Okay, so the question is, this chart shows Gerald's distance from home. We want to know how far was Gerald from home when he started his travels for the day. So assuming he didn't start at home, he was somewhere else. Maybe he's on vacation and he traveled a little bit one night and then he kept going. Whatever the situation is, he did not start at home. So as a hint, I want to know my initial condition. Remember, just like before, it's the distance he's traveled when the time is 0. Okay, the distance he's traveled when the time is 0. If I wanted to make a graph, and I would encourage you all to make this graph, here's my distance, here's my time. So when time, I apologize, that was a little bit messy. When time is at 0, t equals 0, how far is he from home? And we already know, based on the data that's given to us in this table, after 1 hour has passed, so here's my 1, he is 60 miles from home. After 2 hours have passed, he's 90 miles from home. So he's going farther and farther away from home. After 3 hours have passed, he's 120 miles away. Okay, but I want to know, how far was he from home right when he started, right when he walked out the door of wherever he was staying that night? Okay, so to find this initial condition, there's a couple different ways we can do it. We can just look at the table, okay, and we need to know his distance when time was at 0 hours. That's not given to us. Okay, it tells us at 1 hour, at 2 hours, at 3 hours, but we don't know 0 hours. So we're going to have to add on to our table. I'm going to do that over here because that's where I've got room. At 0 hours, I want to know how far was he from home. Let's look at this and see if we can notice any patterns. So at 3 hours, he was 120 miles. At 2 hours, he was 90 miles. At 1 hour, he was 60 miles. Do you notice any pattern here? All of these numbers are changing by how many miles? 30. So it makes sense that when I subtract 30 from 60, I'll get 30, and that is his distance at 0 hours, or that is our initial condition. Okay, at some point we're going to look at some charts, and it's not even going to have any description at all. It's just going to ask, it's just going to show you a table of values just like this, and it's going to ask you, what is the initial condition, or what is the y-intercept? And you're always going to be looking for this point where x equals 0. Okay, and x is usually given by time, if I didn't label that. Okay, sometimes you may need to add on to your chart because it won't tell you when x is 0. But in this case, we just found that our initial condition is 30 miles. That is how far he is from home when he starts. All right, so remember, what was our second goal? Now we have to find the rate of change. So I'm just going to go ahead and use my formula, which is change in y divided by change in x. I can use any of these points because it's linear, so my slope will be the same no matter what I use. So I'm going to pick 290 and 160. So I'll say 90 minus 60 divided by 2 minus 1 comes out to be 30. Okay, but again, let's be precise. Let's use units because it does ask what does the rate of change represent. So I will say the rate of change represents Gerald's distance traveled per hour which in this case is 30 miles per hour. All right, we're almost done because we found our rate of change, 30 miles per hour. We found our initial condition, 30, which miles, which is also, they happen to be the same. Let's put it all together and construct an equation, our goal number 3. Looking at this, I'm trying to see where there's room. I'll just do it over here. I'll just sort of make another little box. Y equals mx, which is my slope, in this case is 30, x plus 30. There's my equation. Finished. I found my initial condition, I found my slope, and I finally put it all together and wrote the equation. All right, please make sure that this is in your notebooks, and then the next video you're going to watch sort of walks you through some of the problems and the problem set that is due tomorrow on Thursday. So please find that on YouTube next.